My name is Sangeeta. I am studying second year B.Tech in Adishankara Engineering College. Today's topic is asymptotic notations. What is asymptotic notations? Asymptotic notation is used to describe the running time of an algorithm, how much time an algorithm takes with a given input n. There are three different types of notations: big O notation, theta notation, and omega notation. Big O notation. The big O notations defines an upper bound of an algorithm. It bounds a function only from above. For example, consider the case of insertion sort. It takes linear time in the best case and quadratic time in the worst case. We can safely say that the time complexity of insertion sort is big O of n power 2. Note that big O of n power 2 also covers linear time. If we use theta notation to represent time complexity, the insertion sort, we have to use two statements for best case and worst case. The worst case time complexity insertion sort is theta of n power 2. The best case time complexity of insertion is theta of n. The big O notation is usually when we only have the upper bound of the time complexity of an algorithm. Many times we easily find the upper bound by simply looking at the algorithm. Big O of g of n equals to f of n. There exists positive constant c and n theta such that theta is less than or equal to f of n less than or equal to c star g of n for all n is greater than n theta. This is the graph in omega notations. Just as big O notation provides an asymptotic upper bound on a function, omega notation provides an asymptotic lower bound. Omega notation can be useful when we have a lower bound on the time complexity of an algorithm. As discussed in the previous post, the best performance of an algorithm is generally not useful. The omega notation is the least used notation among all three for a given function g of n. We denote by omega g of n the set of functions. Omega g of n equals to f of n. There exists positive constant c and n theta such that theta is less than or equal to c star g of n less than or equal to f of n for all n greater than or equal to n theta. Theta notation. The theta notation bounds a function from above and below, so it defines exact asymptotic behavior. A simple way to get the theta notation of an expression is to drop low order terms and ignore leading constants. For example, consider the following expression: 3n cube plus 6n square plus 6000 equal to theta of n power 3. Dropping lower order terms is always fine because there will always be a number n, after which theta n power cube has higher values than theta of n square, irrespective of the constants involved. For a given function g of n, we denote theta of g of n is following set of function. Theta of g of n equals to f of n. There exist positive constants c1, c2 and n theta such that theta is less than or equal to c1 star g of n less than f of n less than or equal to C2 star g of n for all n greater than equal to n theta. This is the example of theta graph of theta f of n equal to theta of g of n. Thank you for giving this opportunity.